come back.
In this video, we are working on sequences and series, specifically a question on sigma notation and a geometric series referring to convergence. We have to prove that this expression here is a convergent geometric series. So the big idea is whenever you are dealing with a convergent geometric series, there is one particular thing that you need to be able to remember. Well, there's one particular thing that you need to know about all convergent geometric series, and it is this. Your value for r, which is your common ratio, will need to be a value that is bigger than -1 or smaller than +1. So it basically needs to be a fraction that is smaller than +1 and bigger than -1. So in our case here, what we also need to recognize is that a convergent geometric series will also be a geometric series that has a sum to infinity. Hence why what we have here is labeled or sketched out like this. So let's just start from the top, right? We have a sigma symbol here. This sigma symbol already tells you that you are going to work with some kind of Sn formula. Within your formula, right, we know that this is telling you that where you're starting off is where your value for k is a 1. This is not always a 1. This can be a 2, a 3, or whatever. It doesn't matter. But depending on what this value is, if you throw that in there into your equation, it will always give you the first term of your sequence. That's super important. I know it sounds weird, it sounds crazy, but just hear me out. If this value is like a 4, right, and you throw a 4 in there, whatever this pops out, that will be your first term. Okay, you have to remember that. So this gives you where you're starting off in your sequence. It will technically give you your first term in your sequence. And again, this does not necessarily always need to be a 1. Secondly, this is always the formula that is generating whatever sequence you're dealing with. And then this will tell you where you're ending off in terms of how many terms within that sequence are you adding up. So in our case, we see here at the top, we have a sum to infinity symbol. So automatically that tells us that this expression, whatever we're doing, we need to work out the sum to infinity of that sequence. However, this question wants us to prove that this sequence or the sum that we get here will be for a sequence that is geometric and a geometric sequence that is convergent. So I think I've just been blabbing way too much. Dude, just get to the point. So to make things simple, when you're going to prove that a sequence is a convergent geometric sequence, what you need to do is whatever sequence you're dealing with, find the common ratio, because any sequence that is convergent and geometric, we know that it will always have a common ratio. So let's find the common ratio of whatever sequence we're dealing with. So to do that, what I like to do is, we know that we have to start off where k is a 1. So what we're going to do is we're going to throw k as a 1 there, and then we're going to throw k as a 2 there. So these two values here, we know that the first one is just a 12, the second one is just a 4. So we know that our value for r, we can work it out by doing this, right? A second term divided by the first one, 1/3. So our value for r is a third. And if you check there, our value for r is definitely a value that is bigger than -1 and smaller than +1. We have technically proven that this is a convergent geometric series. That's it. 3 marks, I know. This is generally a 3-mark question in an exam, and all you need to recognize is when you see stuff like this, right, this is telling you that you're adding up a certain amount of terms in a specific series. You see, that's why you have a sigma symbol there. What you can focus on is basically your formula, right, and also where you're starting off. Your infinity symbol there, for this kind of a question, it really is not necessarily doing much. However, any sequence that is convergent always has a sum to infinity, so hence why that's there. So it's not necessarily a big deal. Whew. So yeah, this tutorial is short, and if you haven't already, be sure to subscribe, because I mean, the tutorials are coming. I know this channel has a ton of tutorials already, but more are definitely coming. And the good news is there are now online courses. I think I think a few of you have signed up, so which is dope. So with the online courses, they're basically more structured and all that. More info on that in like more tutorials that I'll be making. One other thing, right? Within the comments, obviously, when you ask a question, I get a notification and I'm able to respond immediately. In the sense that if I'm not busy and you ask an important question, I'll definitely be able to get back to you.